I audible? Yes. Thanks, Rob. Good morning. It's wonderful to be here. You know what? You and I are making history today because this is the first ever EventCentric conference, and this is the opening session. And also, I hear that this is the first time they're hosting DDD and the other conferences in this center. So, all good. So we are in a good place. I know this is the opening talk, so I'm not going to, go on into hands-on coding to, drain your brain. So this talk is more about some of the mistakes and, the best practices that you can think of when you go back to your organizations and teams to put in practice, or at least to have a conversation and discussion on these things. So, as a software engineer, what comes to your mind when you see this picture? Anyone? Exactly. Coupling. Coupling is as old as the software engineering industry, and is also as new as what we are doing current ages. It's been talked about a lot in the past. It is still being talked quite a lot in the current world. And even a new book came up recently, Vlad, you might know him, and it talks a lot about coupling and complexity. It gives you kind of a new perspective to take on this old topic and apply and consider as we do even the AI development these days. And there is an interesting concept that Vlad mentions in that in his book. So this is the pictorial representation of our solar system. So you think of these planets and the sun, right? So they are millions of miles away. They have nothing to do between them. Is that the case? But Vlad says no. Because if you consider the Earth and the sun, even though both are like more than 150 million miles away, there is still a connection and coupling according to Vlad. And that is true, right? Because the gravitational force. So that is the essence of his book. He talks about the distance between the different systems and coupling, factors and the effects of coupling, etc. So we know that coupling is connection. Coupled means connected. But the question is, everything is coupled these days. Why do we always hear that, oh, coupling is so bad, that's horrible, you shouldn't do coupling, etc. For that, I need to tell you a story. So here is a simple architecture, one of legacy system I worked on many years ago. It's a simple one. On the left, you have the web front end, middle graph, so the API gateway layer, and the back end, a legacy e-commerce platform of those days. And it worked with a bunch of other applications, as you can see. Now, when the front end makes a request to place an order, a call comes to the API gateway, then the call goes to the back end. The back end service interacts with a bunch of other applications to fulfill the request. Then one day, say Black Friday sale, the traffic peaked. It got over the roof, and the system struggled. One after the other, things collapsed. So one system went down, that brought the other one down, and eventually the entire website was down. So you might think, if the order service is what causing the trouble, why couldn't the customer browse the products on the website? Why the customer couldn't look up their loyalty points on the website? Why everything had to go down? It's because of this reason. All those applications were tightly coupled. So one after the other, things were brought down as a chain reaction. So if tight coupling is bad, it's because of the high degree of interdependence. And we consider that, loose coupling is good because the dependency is minimal, and there are ways that these loosely coupled applications interact. So what gives us loose coupling then? If that is something good. So to loosely couple, so we need to think of independent systems. And these systems may exchange messages. So they send messages, and the other application kind of takes its time to process the messages. And most importantly, they deal via events, right? So events gets published, and another application subscribes and reacts to that event either immediately or when it has its own free time. So that brings us to events, and events means event-driven architecture. So welcome to my talk. My name is Sheen Brisals, and I'm in the industry for many years, since the early 90s. I've been through several technologies from the past and the newer ones. For the last 10 years or so, my focus has been more on AWS and architecting cloud adoption, and also specifically working with serverless technologies. When you think of serverless, there's event-driven architecture is all over the place with serverless. So last year, I co-wrote this book. It's about serverless adoption on AWS, and currently, I am planning to bring out this book about conference speaking. Speaking of my AWS book, the free copies are available to be given away. So keep an eye on the Slack channel for the raffle draws. Right. Okay. So what are we going to look at today? I'll give a brief introduction to event-driven architecture. I won't go into the details just to set the scene, and then we'll look at a few of the the mistakes that basically we do, or missteps that we do as engineers, and how DDD and its bunch of other technologies or practices come and help us, and then we will wrap up with the takeaways. In terms of event-driven architecture, let me start with a simple thing. So there are two services. Say one is a client application requesting the price of a product. Okay, that is a typical synchronous call. So it fetches the price and returns back, because behind the client is a customer waiting for the price. So that's fine. And let's move on to a different service situation where we have two services. Service C is, let's say, it's a order shipping service, order fulfillment service. And service D is a payment service. So as I was saying, that service C, say, assume it's order shipping, and service D is a payment service, right? So what happens is many retailers, they take the money from the bank, what we call the capture or settlement, only when they ship the order, and before they authorize. So say service C sends a bunch of, let's say, hundreds or thousands of previously authorized payment IDs to service D to capture. Capturing funds requires going out to banks and stuff, so it takes time. It may not be in a few seconds, could be minutes or even weeks. So what service does is sends an acknowledgement, I got your request, okay, I will deal with that. But the question is, how does C know that D is doing something? So D kind enough to provide a typical status endpoint where service C can poll, have you done this? Have you done this thing, etc., etc. But C has problems. So it has basically three problems. One is, how soon should it start polling after submitting a batch of requests? How often should it poll? 1 second, 1 minute, 1 day? How long for? You can't keep on polling. It has to know when to finish polling, right? So this is a problem that typically we have with these sort of query patterns and things. Instead, what if same thing happens? Instead of doing the service status polling, D sends an event back when it captures a fund. So we are now getting into the event-driven territory. So behind this notification, you can think of there is a broker that carries the notification message. It is also the case that with between services, as I mentioned earlier on, message queues are there, so that services are loosely coupled. They're not tightly kind of integrated. But again, it depends on the scenario or the situation. So in terms of event-driven architecture, is basically the communication that happens via events in an asynchronous manner. So that is the typical sort of event-driven architecture. Now, there are four main elements of EDA. So there is a producer that publishes the events or produces the events to a broker or a bus or a carrier to take the message, to take the events to its consumers. There are applications or services around. They look for certain events to perform something. So producer, consumer, the event broker or the bus are, and the most critically, the events. So it's all good. Event-driven architecture is all over the place. Everyone is doing it. You keep hearing the messages that, it's fantastic. That company is doing event-driven architecture. We are in an EventCentric conference. We do have event-driven architecture days as well, so that's very popular. And there are so many books, so many training courses. So it must be good, right? As an engineer sitting there, you think, oh, awesome. EDA is awesome. Everyone should do that. Then there are people, oh, okay, not really. 2 weeks ago, I was having a conversation with an engineer who is so against EDA. There's no way I could convince him to introduce EDA into his organization because he was explaining certain things that he didn't like, which I will probably touch in my talk as well. That's exactly why some of the pain points that people see with EDA. So let's start with something very common, especially when new teams, startups or new teams begin experimenting with event-driven architecture. Because this whole concept is new. So they start something simple. Okay? In a team, they do sort of event-driven activations. They keep kind of, adding more things, experimenting. Then slowly and slowly, they keep adding more and more services connected via event-driven, architecture. So imagine that behind this, there is an event broker or a bus that carries the message. Now, they start with an MVP, and the business will see that's a perfect opportunity. They will convince them, oh, this is good. Let's take it to the boardroom. And then board will say, oh, wonderful. Let's publish it. Give it to customers. Then that goes out to public. And then they will come back and say, you know what, this is so popular. Let's add something new here, new there. So they keep adding. In a few months' time, what they will have is a gridlock of event-driven applications. They can't do anything. There's something came up a while ago when AWS Lambda was popular. This is the pinball, right? So if you play, the ball bounces up. So they termed that as Lambda pinball architecture because this is typically what happens with when you adopt cloud, so that you use one service and goes something else and then comes back and bounces around all the time. So this is typically what these teams get into. And especially because they haven't really got the understanding of structuring the applications to make it efficient to work with EDA. Now, the second thing is the opposite. So teams, they have structured systems. Let's call them systems for now. So they have their own kind of territory. They have event brokers. They happily connect with and to communicate to send events and receive. And they have resources. This is quite common in the cloud scenarios, cloud adoption. Then what happens is engineers find that, oh, you know what? This service called EventBridge from AWS allows you to send notification or invocation to another service in a different system or a different account. Oh, wonderful. Why do we need to then go via a broker and set up the filtering rules and subscription rules and all sorts of things? We have the freedom to invoke a function from another application. Then they start slowly putting that into practice rather than doing a clean kind of broker-to-broker communication and then subscribing from the broker. They just go weird and wonderfully connecting everything together to make a complete gridlock of monolith application. So this is typically common in teams adopting cloud and using these sort of cloud providers, event broker services. Like typically AWS has EventBridge, EventGrid in Azure, etc., etc. So that's one pain point. And then the dealing with duplicates. Many teams still don't do this properly. Now, if you consider the simple thing I explained earlier, as a saying goes, everything fails all the time, right? It's our responsibility to make things happen. So network failures, consumer is not ready to receive the event, or the quota exceeded, you can only take up this much per day or per hour. We don't consider any of these things. We just kind of retry. That has its own problem, retrying, right? So what happens, with that chaotic situation is that things, start to break, and there are events that, more than once get through the system and end up into a consumer, and consumers are not ready to deal with that situation. And it can cause huge implications to the business and the morale of the teams and things. So this is another situation where typically when you adopt event-driven architecture, you get into. And then you have the classic of breaking contracts. Still, EDA teams don't think events equal to APIs. That thing is still not there with everyone. So this is the same picture. I added a few more boxes. Imagine this situation. There is a event. It has a date of birth, the typical DDMYY. Assume that a US corporate acquired this company, and they say, oh, why don't we change the date of birth format to our format? That is just the opposite, right? Now, this won't visibly make much complications most of the times. But this is something that teams struggle with. Not exactly this one, but similar changes. Changing the meaning of the data or an attribute without considering the consumers. Because for the producing team, it's fine. They did all the changes with their testing because they know where to change. Then it causes so much trouble. And the other one is explicit change. So date of birth is a big PII issue these days. You're not supposed to ask the customers. So instead you ask the age and say when you recorded the age so you can work out the age. So they do this change. They make the changes. They do the testing because they know what to say. But someone millions of miles away in Mars, they have no clue whatsoever with this happen. So that puts applications on fire, and that's when the engineers get grumpy, and there's a heated argument, all sorts of things going on in the organization. The low morale and everything that happens within these sort of implementations. Of course, the loss of revenue, and you can think of the consequences. And then the tracing nightmare. So this is classic because distributed system, when you have services scattered, dotted around all over the place, you have no clue where the sequence of events going through, because we need all these systems to work together to provide something. But we have no idea. And typically when it comes to distributed system, is it right to think of two ends? Because do we have two ends? Because you never know where one leads to the other and then goes to where. So we may have customer journeys, but beyond this, so many things can happen beyond that. So in these sort of situations, when you have multiple teams and applications working together, this is a real pain for event-driven architecture and for engineers kind of implementing the architecture. So this again kind of comes down to engineers wasting their time, observability tools issues, and logging is typical because you can't log everything these days, right? Because for sensitive data and GDPR, etc. So when all these things come up and the engineers get frustrated, that's when you hear this, someone shouting, it's so complex. Of course, yes. The two things usually people brand as complex these days. Event-driven architecture, complex. Distributed systems, hard. Yeah, so don't go there. But the question is, let me ask you something. What is not complex in our lives, right? So I'm standing here, owner of one of the most complicated systems in the world, my body. I'm still managing it, right? So take, for example, a simple takeout or takeaway application. You think that Few clicks, you get your food delivered. Do you ever imagine that there's so many components behind the scene working together to provide that, the takeout experience? The thing is, if the phone, app fails, they should be able to provide via the web. If web fails, at least the phone order should work. So this is how systems, engineers and architects think these days. And that's exactly the reason why we are getting into the event-driven architecture. There is Tesla's law about complexity. He says that every application has some element of complexity. There is no way you can avoid. All you can do is push it here and there, and and manage the complexity. That is exactly what happens in our situation these days. And given that, how can we at least try to do something on EDA? Right? So how can we untangle the complexities? But according to pundits, that is a problem for us. Decomposing systems is a problem for software engineers. However, let's see if DDD can help us to think differently and bring that kind of structure. So this code, I like this code because this is often what we do. When we are faced with a complex situation, we try to find shortcuts to kind of do ad hoc things and make it look simple or feel simple. But that will have its consequences later on. Okay, so the first thing is, to prevent entangling your architecture, you need to decompose your system. But I would say, before you decompose your system, your business must be untangled. So this is where we think of the Conway's law, right? If you are a bunch of people sitting together and developing something, you are likely to develop a well-integrated monolithic application. If you're all distributed and across different teams and departments, you're likely to build independent systems and communicate. They communicate via contracts and things. So that is the case. So domain-driven design, I often say that it's not a book, it's an industry. Because the reason why we are here, the reason why all the workshop that happened and happening and all the training and everything, what Eric has given us is basically an industry for us to thrive. Anyway, so DDD, if you are familiar, is basically approach to model the business. So with the certain practices and patterns, how to kind of structure the organization or the business into manageable parts. So it starts with domains. Domain is basically what your organization specializes in. Okay, it could be finance, could be kind of banking, or even could be multiple. Like for example, if you take Amazon, so they do retail, and also they do Amazon Web Services, right? So it depends. And also an organization can kind of have one domain, and they also call how they split into also as subdomains. So then once you have domain, then we get into subdomains. Subdomains are further kind of classification of the domain into more kind of grouping together things that happen for a purpose. So there are kind of three main subdomains that DDD talks about: the core domain, generic, and supporting. The core is basically the differentiator of your business from the other business. So that's where your business logic. If you think of the cool engineering activities happening in your organization, that's probably where to support the core domain, because that's your knowledge, brain power. And generic subdomain is basically something that you need for the organization, but it's not differentiator. For example, the human resources system that you use may be the same system that we use in our company. But because that is the same, there is no point in wasting time. And having said that, so especially when you have these sort of third-party applications, that's where the event-driven architecture has a big part these days, especially to consume and process the events. And after subdomains is the most important things happening, what we call the bounded contexts. Bounded contexts are where a particular model makes sense, or a language, what they call the common language, makes sense. For example, if you're thinking of a shopper, in a checkout, bounded context. It's a, customer. But the meaning of that shopper in checkout could be different to a similar loyal customer in the rewards area, because they are kind of, the different models between the different subdomain and bounded context. So the beautiful thing with the bounded context is it allows to evolve the system. Many organizations, what they do is like, if a particular department or a director wants funding for certain new development, they need to kind of take it to the management board, explaining this sort of boundary, and then that boundary will be kind of funded by the board or however they structure. Once they have the boundary, then they can start the next process. I'll explain next soon. So that's the kind of the boundary or the bounded context thing. But question is, how do you find the boundaries? It's easy to say and draw the pictures, but finding the boundaries is not that easier. That's where another beautiful process comes in, event storming. How many of you are familiar with event storming? Wow, wonderful. Okay, so that's really good. So event storming is a collaborative process that brings business domain experts and engineers and architects and everyone together to kind of chart the flow of a system or the process. So Alberto, who is here, and he's speaking, also running workshop, he got the idea, the inspiration from domain-driven design. So that's how he got it. And according to Alberto, this is what he says. That's true in many cases, because the engineers, if they don't listen to kind of the domain experts, what goes into production is completely, not what the business wants, something completely out of thing. So anyway, just to explain in simple terms how to identify the boundary. Let's say in a timeline, you start, the charting a process. So there is an actor, say customer. I as a customer, I'm holding a reward, and I want to redeem my reward. That is a command. So I'm asking to redeem. So that means something has to change, right? So I'm acting on, that acts on the rewards aggregator or object, however you think, or the entity. So that's sort of the, the data model that you have. And then once you acted on, it must do something. So you redeemed your reward. So that is an event. That is a domain event that going out of your system, right? So this is a simple way of progressing how you identify the events. But thing is, so that happened, what happens next? So someone redeeming an order probably have an effect on the order. So order needs to be recalculated, right? So then that works on a different aggregate that's called order. So you see the meaning of now slowly kind of going away from rewards to order. So that's when you identify certain events as pivotal events and then say, oh, that is the boundary for this one, because on the other side, they talk a different language or something different. So this is a simplistic way of explaining the event storming process. So there are two basic approaches. One is the high level, that is a big picture that when you start, when you don't have any clarity, like when I mentioned that subdomains, bounded context. So that's where you start the big picture. The design level or the development level, what I call, is so important and happens in the engineering teams level. Especially when you pick up a new piece of development or new feature, always good to bring everyone together, engineers together, and do an event storming session. You'll be amazed to see how productive they become and identify the events. And moving on, now that we have boundaries or bounded contexts, we need to guard those boundaries because they need to be protected. So this is where a new thing comes in. So to guard a boundary, you need, of course, people and principles and process. I mentioned that directors go to board for funding. So they pitch that they need a new team for this particular new boundary or bounded context. So what we bring now is a different pattern, a team pattern or practice called team topologies. Who has read this book? Who is aware of it? Okay, quite a few. It's interesting because when I speak in the UK and the Europe, I see quite a lot of hands going up. But in the other parts of the world, in my experience, not many people know. It's a wonderful, thing to know about the team topologies, how they kind of, propose the different types of teams to, organize the teams. So team topologies wise, it has kind of four, team groupings, enabling platform teams and the stream-aligned teams and the subsystem teams. So stream-aligned teams are more like you think of your feature teams or product teams to get something out. So those probably the teams are the ones guarding those sort of business-bounded context and do the development. So that means each bounded context now has a team to work with. So those teams are now the custodians of those boundaries. So this is the beauty of the team topologies, what it brings. So bringing it together, this is typically how you will find in an organization split into this sort of level. So there is a bounded context. I drew hexagons, but think of any applications and other things. There is a owner team that owns this bounded context. And then in many organizations, this team that owns the bounded context also operates the application. If it's a cloud, they do that operation. Because you think now there are multiple bounded contexts around, they all do communication via the proper mechanisms like APIs and events. Okay, so from there on, let's look at what can we do to prevent contract breakage, especially with the event-driven architecture and events. So you're familiar with synchronous contract, APIs, and event contract, asynchronous communication. So let's focus on the event. Let's give them some care, being an event-centric conference. Now, when something happened, this, and change in the system, event is an immutable capsule of data. So the data envelope normally you don't change. Now, for an event, the first thing is belonging. It must belong somewhere. You can't have orphaned events, for example, for effective event-driven architecture. For that, let's start with domain events. So domain events, according to DDD, events that happen in a particular domain, bounded context, as I explained early on. And these are all kind of considered as domain events. Hold on your thought. I will explain different types and things later on. So let's see. And here is a small snippet of an event. It has its belonging. It knows that, it tells that, oh, I have come from this domain, this is my subdomain, and this is my source or the service that emitted the event. Okay? Someone receiving it will know where this comes from. Now, the second thing is, it must have identities. How many of you, when you consume an event, consider the version of the incoming event? Okay, just a few. That is a mistake many teams do. They just don't look at the version at all as part of their subscription rule or the filter setting. So in this snippet, I have a version, and then you add an event ID. So this is again kind of debated. People argue that when you use event broker, the event broker also adds the event ID, for example. When you create an event, it gets an ID. Why do you need to put your own ID? I always recommend adding your own ID because when it comes to, in certain situations, retries and replays, certain brokers add a different event with a different ID. So you lose the originality of the ID. So that's always recommendable to add an event ID of your own. So that can kind of go along to different systems. And then you have the trace ID for the purpose of the distributed tracing and everything else. Some organizations even add data blocks to say that you can't change this data at all. No matter wherever the event ends up, say, for example, tracing ID, that never changes. Because sometimes when a particular system relays an event, it creates a new event with a new ID. but still carries the same tracing ID it received from its upstream, producer. So there are different ways that teams kind of, do things to make everything proper. So to handle to handle duplicates, idempotency is something core to every team that practices event-driven architecture. Without this, don't just do EDA, simple as that. So what is, how can you do idempotency? So idempotency, when you have duplicates, you received an event, you process the event. Same event comes back, what do? You shouldn't change your system, state and things shouldn't change because it will have far-reaching consequences, right? So this is why there are mechanisms how you can kind of, deal with that. Say, for example, in this case, the finance system receives a duplicate event or event, first of all. So what it does is basically it stores the event somewhere, however you call that, event store or, index store, etc. Then it looks up, have I got this event before? And then if it did, then it just ignores it, or with bunch of housekeeping things for logging and etc. And if it's a new event, it stores the event first and then processes it. So this is a typical thing. And you might have heard of these two patterns, outbox pattern and the service first pattern. This is exactly the storage first pattern. This is exactly that one. You store and then process. You may think that there is overhead. I will tell you why. Imagine the finance system is now talking to third-party applications. The third-party application could be down. So that means your circuit breaker will tell you that, oh, that's down, you need to replay at some point. So when you come to this sort of replaying situation, it helps you to check or even record the status of your replays and before successfully pushing the data to the third party. So it has so many kind of benefits comes with the implementation. And common event structure is crucial. So far, purposely, I've been kind of showing this structure to you, event structure. There's nothing wrong in that. It has everything. But it kind of mixes your kind of business thing with non-functional thing, functional and non-functional, for example. So this is why I always recommend spend time to separate out things. So bring something like a metadata and data section to your event. So that way, you have more freedom to add things as you wish into respective sections. So for example, in the metadata section, now you add everything about the event identity or the belonging and other things. I mean, teams even do TTLs and you can do the callback URL or tokens and so many other things. So it depends on your implementation, but really makes, and also it helps the subscribing teams when they set up the rules to get the events. Say, for example, payments may say that, oh, I only need events from, I don't know, this domain and this particular service because that's what I'm doing. So that helps to, when you do a JSON path or however you do the filtering, helps to just stay there. You don't need to kind of look into the, the data parts. And the data is actually your kind of instant data or the business data. So this is something important, and many organizations follow this approach. And for clarity, you can classify the events. So this is debatable, but this is my way of kind of advising. So think of different event categories. So we talked about the domain events. There can be other events as well. So it can be, you can have private events, or you can have operational events. You can have the local events. And also these days, you have, when you work with cloud providers, they also kind of pump out tons of events, right? So you can always kind of separate those things out from your events. And when it comes to types, it's about, again, how you kind of use it, like commands and the data and status and things. There's no hard and fast rule, but it is up to your organization, your team, how you see these, categorization benefits. I'll explain one or two things later on. So for example, this one has category of, this is a domain event, it carries data. But there are different interpretations. So for example, Vlad in this book, it talks about three things: event notification, state transfer carrying, and the domain events. So in terms of event notification, this is a brief event. It only has, few things, and it won't carry the entire data. But what will carry is like a URL for anyone who wants the data can go back and fetch. This is something, you're probably familiar with the claim check pattern. And this is true that, for example, if a producer is producing an event, if only 10% of consumers are interested in the data, why bloat the event envelope with all the data? Instead, provide a secure mechanism to fetch the data. And this is quite common, especially when it comes to dealing with sensitive data, and you only kind of provide the data to who needs that. And the state transfer is basically the snapshot of the changes that happen. It's probably a bulky event, and typically then we have the domain events that carries the the data that happened. And then in another book, you find a different interpretation. So in this book talks about the internal events and external events, like what I mentioned. So internal events are within your bounded context. So this book argues that because it's internal, you don't need to worry about versioning. Because if something breaks, it's within your thing, it will never leave the boundary to go somewhere. So that's when you have the external events. So the external events you can think of like the domain events going out of your bounded context domain. So that's all to do with events. Then let's wrap up with a couple of the patterns. So the two most common patterns in EDA are one. Anyone? Sorry? Orchestration. Yeah. Next one. Choreography, yes, of course. So choreography is quite popular. I'm not going to go through the details. And orchestration, it's a companion, again, so popular. You need them for the typical saga pattern implementation. There is a talk later on here focusing more on these two patterns. So, tune to that. And let me take you to something close to DDD, that is the anti-corruption layer. How many of you are familiar with anti-corruption layer? Quite a few. When I speak to engineers, especially the new generation engineers, they haven't heard of this. Because not many engineers know the domain-driven design at all. So for anti-corruption layer, no idea. But then you talk to them, you make them understand, then they get the point. Then they say, oh, I knew it before, etc. So it's basically one of the collaboration type, the patterns in DDD. So this is mostly, this is based on the consumer supplier pattern or the published subscriber. So this is crucial when it comes to domain-driven architecture. The reason I will explain is because it provides the translation between two bounded contexts or two models. That is crucial. Because if you don't, things can easily get into a messy situation. So this is basically what it is. So you have an upstream or a supplier. It is pushing some data to you to consume. So assuming you are a consumer, what you do is you don't just accept everything that comes in and dump into your data model. You think, you put a translation, your transformation layer, and then you just kind of take it to fit into your data model. So that way you always keep your data model pure. So as Vlad cleanly mentioned in his book, otherwise this is what will happen. If you don't, that's what happens. So to give you an example, so here is a bounded context. So for example, it kind of communicates with a bunch of other bounded context services and third-party applications. Makes a call to payments. That's a synchronous call. It probably gets a response. But payment systems also send asynchronous events. Now, payments, that may be dealing with a bunch of consumers. So they're not going to kind of translate that to your need. So what you need to do is like you put in an ACL layer so that you ingest the data and kind of translate to your need. Similar to other things. So most third-party applications, interactions, you can easily have a layer to kind of translate that. And same with when you communicate with the event-driven architecture, there are ways to set up the ACL and also the other one, the OHS, the pattern. So though I showed us simple boxes of ACL, think of building them as microservices. I always recommend if you have an interaction part with your third party, wrap that into a microservice. So because in future, if the business decided to change the third party to somebody else, all you need to do is just bring a new microservices and slowly strangle the other one away. So it makes you, your job easier, especially when you deal with all sort of, the complex situations. And similar to this one is a gatekeeper bus pattern. This is something related to, I originated from working with AWS Event Bridge. It's basically acting as a guarding bus to your bounded context. I'll show you an example. So in this book, we ask that, so when you have APIs, you are so careful about, of course, the contract, then you think of the quota, throttling, and nobody can hit you with a million requests per second or a minute. But what do we do when we deal with events? We don't care, right? So it just flows or comes in. So this is why it makes sense in some cases to think of event gate to have the proper, control. What comes in, what goes out. For example, when you work with the event broker, most likely you have an enterprise event broker, then these applications or bounded contexts may have event brokers within. So that means they can act as the kind of gatekeeper to push something to the enterprise broker or consume from the broker. So this is a way of kind of guarding and controlling a mechanism. To put you in a context, say imagine this is a typical bounded context. You have a bunch of microservices. In the middle, what you have is the event broker or event bus. And then it deals with few external applications via HTTP calls or event communication. Now the thing is, not all events, as you can see, are domain events. For example, the status change as part of your the circuit breaker service. Why should it be going out? Why should it go out? And also something pay by link, customer click the link, and that's probably something for the payments to deal with, not necessarily for an external application. So there'll be hundreds or thousands of different types of local events floating around. So those events have no kind of meaning to outside. So that's why I propose that there is a special event broker or a bus that you keep to guard the boundaries so that it has all the external rules that you need to deal with, and also it can kind of you can easily wrap that into a microservice similar to what I mentioned earlier about the ACL. So you can do the translation. For example, if finance domain needs the event as cloud events or a different async API format, so it can do that sort of translation and the things so that the internal services and the bus, they are safe or secure from, all the external communications. And finally, the event sourcing. So event sourcing is basically to keep, store your events and, replay it. That's the typical thing. But these days, it's not necessarily the replay purpose. It also serves a bunch of other purposes. And so this is kind of a simple example where account created or updated, deleted, you record all the the happenings in a way. I see there are three ways you can do event sourcing. The first thing is within your bounded context, and the other one is domain level. It's kind of higher level. And the third way of saying is the centralized. So bounded context is like when you have a boundary, you have a dedicated event sourcing service. So that will kind of catch all events happening within the bounded context. It stores its own event store, and that's the event sourcing mechanism you have. The domain level is basically a bunch of bounded contexts, pushing all the events to the event broker, and there is a dedicated team or dedicated service that takes care of event sourcing. Centralized is something similar to centralized logging, if you are familiar with. So this is when you have kind of vast amount of cloud accounts and regions you operate, then you have the sort of the high performing event broker that kind of acts as the broker for everyone, and then you have a dedicated account and service. This is more common in sort of secure environments or highly regulated where not everyone can get hold of the data, etc. The reason I mentioned about event sourcing is useful is because it also these days serves us for debugging purpose, for customer issue mitigation, because that's where you can store everything. Not just event, many teams also convert every request and response coming in and out of your system as events and persist, because that is the true way of knowing what happens. Because for reasons I mentioned earlier on, you can't pump everything into the logs. That is a huge security risk. So that's why teams rely on the event sourcing for that purpose. Okay, so just to wrap things up, so event-driven architecture, yes, wonderful, but as many say, it has its own problems. So that's why we need to clear up the business to bring kind of purity to the engineering side of things, and in doing so, we become so modular. Modular means it has so many benefits, from observability to evolution of architecture or fast flow and so on and so forth. And in terms of patterns and practices, there are a bunch of patterns and practices out there. So it's a matter of kind of getting familiarity with those things and slowly putting them in practice. Many organizations are already ahead of the curve, but there are still so much to do in the industry. When I speak to organizations, when I speak to engineers or teams, I understand how much behind they are compared to some of the other teams in the industry. Now, there is a need for distributed architecture and EDA because of our needs. We ask for it because to supply us all the demands and things as a consumer, these are the needs for us. There's no way going back. So that means all you can do is apply the proper thinking and put in the practices to evolve the system accordingly. So what I'm saying is that complexity is there, but we should be able to embrace the complexity and manage things the better way possible. And of course, the saga will continue. Thank you all so much. Have a fantastic, fantastic conference. Thank you.